to one and all present here. I am Ramya Devi, working as Assistant Professor in SNS College of Engineering. Today I am going to share a small article regarding regression. Regression is a statistical technique to determine the linear relationship between two or more variables. Regression is primarily used for prediction. In its simplest form, regression shows the relationship between one independent variable and a dependent variable. Regression is a supervised learning technique which helps in finding the correlation between variables and enables us to predict the continuous output variable based on the one or more predicted variables. It is mainly used for prediction, forecasting, time series modeling, determining the causal effect relationship between variables. Regression shows a line or curve that passes through all the data points on target predicted graph in such a way that the vertical distance between the data points and the regression line is minimal. Types of regression: linear regression, polynomial regression, multivariate regression, and some examples of regression can be as prediction of rain using temperature and other factors, determining market trends, prediction of road accidents due to rash driving. Linear regression performs the task to predict a dependent variable value based on a given independent variable. So, this regression technique finds out a linear relationship between x input and y output. Hence, the name is linear regression. It can be described as y is equal to f of x. It is fitting a straight line to a set of data points. Generally, a linear model makes a prediction by simply computing a weighted sum of the input features plus a constant called the bias term. Bias is the difference between the average prediction of our model and the correct value which we are trying to predict. In this technique, the dependent variable is continuous, the independent variable can be continuous or discrete, and the nature of the regression line is linear. And this is an example of a linear regression. The equation of a straight line is y is equal to mx plus b, where y is dependent variable, target variable, m is the slope, b is the y-intercept. Calculating linear regression. There are three methods for calculating linear regression. The first one is the ordinary least squares method, the gradient descent technique, the coefficient of determination or R squared. The ordinary least square technique, it tries to minimize the squared error between each point and the line, where the error is just the distance between each point and the line that you have. Then we sum up all the squares of those errors. The gradient descent technique. Gradient descent is an optimization technique used to tune the coefficient and bias of a linear equation. Using the gradient descent technique can make sense when dealing with 3D data. The coefficient of determination or R squared. It is the fraction of the total variation in y that is captured by your models. 1.0 minus sum of squared errors divided by sum of squared variation from mean. Polynomial regression. Polynomial regression is a type of regression which models the nonlinear data set using a linear model. It is used when data doesn't actually have a linear relationship, or maybe there is some sort of a curve to it. Suppose there is a data set which consists of data points which are present in non-linear fashion. So for such case, linear regression will not best fit to those data points. To cover such data points, we need polynomial regression. In polynomial regression, the original features are transformed into polynomial features of a given degree and then modeled using a linear model, which means the data points are best fitted using a polynomial line. The equation for polynomial regression, y is equal to b0 plus b1x plus b2x2 plus b3x3 plus bn xn. Here y is the predicted target output, b0, b1, bn are the regression coefficients, x is our independent or input variable. The model is still linear as the coefficients are still linear with quadratic. And this is an example of a polynomial regression. Here y is equal to b0 plus b1x plus b2x2, and here the line forms a curve. Next is the multivariate regression. Multivariate regression is a supervised machine learning algorithm involving multiple data variables for analysis. Multivariate regression is an extension of multiple regression with one dependent variable and multiple independent variables. Based on the number of independent variables, we try to predict the output. Here the plane is the function that expresses y as a function of x and is that the linear regression equation can now be expressed as y is equal to m1x plus m2z plus c, where y is the dependent variable, that is the variable that needs to be predicted, x is the first independent variable and it is the first input, m1 is the slope of x1 and let us know the angle of the line, and z is the second independent variable. Next is the multi-level models. Multi-level modeling is a statistical model that is used to model the relationship between dependent data and independent data when there is a correlation between observations. These models are also known as hierarchical models, mixed effect models, nested data models, or random coefficient models. And the types of multi-level models are random intercept model, random coefficient model, random slopes, and intercept model.